Okay, good afternoon. We're talking today about nature-based solutions to climate change. And I'm going to start with a quick note about what's been described as the dominant narrative. The dominant narrative is the idea that climate change is solely caused by carbon dioxide emissions that comes from fossil fuels and industrial revolution, all those sorts of things. And therefore, the only solution we've got to tackle that is to cut emissions. The solution, which I'm sure you've heard of, is known as net zero. And I just want to make a point about net zero before we continue. Net zero is a very, very difficult strategy for lots of communities because it relies on big infrastructure change and policy change and a massive investment that's only open to governments and multinationals. So that means that net zero for most communities is disempowering. It puts all the power and all the action in the hands of the organizations that did most to create the problem, and it disempowers the people who suffer most from the problem and did the least to create it. So net zero is therefore, it's almost the definition of climate injustice. The people that did least are most disempowered. The people that did most to create the problem are most empowered. And climate justice is about switching that around. You want to put empowerment in the hands of the people that did the least and give them the power to do something about it. Obviously, we're very interested in alternatives to net zero. Are there any alternatives that flip the narrative but also flip the empowerment and empowers vulnerable communities that they can take action? And we found that narrative by looking at some of the emerging science behind nature-based solutions. This is science that tells us that if you only focus on carbon dioxide, you're falling into a trap that researchers now call carbon myopia or carbon tunnel vision, which is a failure to look beyond carbon dioxide at what the other drivers of climate change are, and therefore a failure to look at what the other possible solutions are than net zero. And when we were first looking around, are there other stories out there? Are there other solutions? Are there other causes? And I came across lots of people researching the fact that carbon isn't the only thing that's central to the whole climate problem. Water is central to the climate problem. What we know now is the first impacts of climate change are coming through a disrupted water cycle. We're seeing simultaneous droughts and floods and wildfires. Those are all symptoms of a disrupted water cycle. And they're sending us messages that we fail to understand. When I say we, I mean industrial Western societies have failed to understand, but these are messages that many traditional societies and our ancestors would have understood immediately. They would have said, look, the water is speaking to us. Water is telling us there's something you have to fix here. And as I began to look into what's going on, I find that this problem of disrupted water cycles, simultaneous droughts and floods and fires, it's been given a name now, it's called climate whiplash. But it's telling us that as well as disrupting the carbon cycle for fossil fuels, we've also disrupted the natural water cycle. And how have we disrupted the natural water cycle? There are three main ways we've done that. One is by deforestation and habitat loss, because plants and habitats are vital hubs in the way that water cycles. And we've deforestation and poor land management, we've disrupted the ability of the soil to absorb rains when it comes. So the rain comes it washes off, it doesn't absorb into the aquifer where we need it to go. Urbanisation, because what we do for urbanisation, all the rain that falls doesn't go into the soil, we just throw it into the drain. We treat it like a waste product. And there's an incredible statistic. Every year, a phenomenal 760 cubic kilometres of water that should have gone back into the cycle. We treat it like it's a waste product and we dump it into the drains. And that 760 square kilometres is a wasted resource, but it's also a waste of climate cooling. And those are the ways we've disrupted the natural water cycle. And water is so intimately linked to the climate, it's been called the global thermostat. And I'll explain a bit more about the science behind it. As a little aside, every COP meeting, the climate negotiations since COP26, has raised the fact that water is central to climate chaos. And in COP26, there was a call to policymakers to put water central in the climate action plans. And that discussion has ramped up every COP since 26, 27, 28, up to 29. In COP29, we had the Baku Declaration on Water for Climate Action that says basically that water is just as important as carbon as an action, but they are both drivers for climate chaos, and addressing both together is the action we need to take. We need to reposition our understanding as think about not just carbon and water hand in hand are why we've got climate chaos and why we've got climate whiplash. And those are the two things we need to fix. And I want to come back and talk about what's the nature perspective, because part of the focus of this conference is about diversity. Natural diversity is at the heart of the solution. And I'll talk a bit more about the science now, and you hopefully will understand why nature and diversity at the heart of the solution. The key thing is plants. Plants, as I've said, deforestation is one of the primary causes of water chaos. Everyone thinks when we talk about climate change, greenhouse gases are the problem. But actually, greenhouse gases aren't neither carbon dioxide or methane or water. They're not the problem. The problem is trapped heat. That's the actual problem. That's the essence of the problem. And if we don't focus on what the exact problem is and the multiple causes of it, then we're not giving ourselves the best chance to do something about it. Trapped heat, it's the trapped heat energy that is driving it's that energy that's fueling storms and floods and all the chaos we're seeing, that energy. It's like a kettle. I use the analogy of think of a boiling kettle. It doesn't just get hotter, it jumps about, it screams, it spits, and it gets dangerous. And that's what's happening to the climate, because we've got the energies trapped inside the climate system that can't escape, that needs to escape. And the normal system, the normal cooling system by which that energy escapes is managed by nature. And the normal system is you've got the heat energy coming down and it's trapped by plants. Plants are basically solar energy transformation engines, and they've evolved to do an extraordinary thing. They manage both carbon and water, and in doing so they are the key to managing climate on this planet. And the essence is there's two things that operate in parallel inside plants. One is photosynthesis. Photosynthesis is how they manage solar energy and carbon. I'm sure you probably know this from school, but they take that solar energy and they use the solar energy to split water molecules and carbon dioxide molecules into carbon, and hydrogen and oxygen. And they throw out the oxygen, or some of it, which goes into the air, which is good news for us. But they use the carbon and the hydrogen and some of the remaining oxygen to build carbohydrates, which are sugars and starches and lignins, celluloses, all the things they build their bodies from. And the carbohydrates, the sugars and the starches are like a natural battery, because those are the things that are distributed by the plants through the whole ecosystem, through their fruits or pumped out through their roots and in their leaves as food for us, food for animals. You can think of that solar energy to being turned into chemical energy inside those compounds, and that's distributed through the entire biosphere as a kind of living chemical battery. All that solar energy is not dangerous anymore. It's been stabilized into a safe form and just stored and used by all life through the coming year to do everything it needs to do. So plants transform the dangerous heat energy into a stable store. And they're also regulating the water cycle, because you can think of plants as they are solar energy transformation machines, but they're also pumps. There are exactly 3 types of pumps. They're pumping carbon, they take carbon and they pump it mostly underground. Lots of the sugars that they produce is pumped into the soil, and there it feeds the bacteria and the fungi and the worms and all the things that help to create a healthy soil. And that's what's known as a liquid carbon cycle. So they're pumping carbon from the air down into the earth, and they're pumping water from the ground back up into the atmosphere, where it forms clouds and brings the rain again in a natural cycle. So they're pumping water up and carbon down. As that water goes up, it changes in the leaves of the plants. It changes from a liquid to a vapor, which is a gas. That change from liquid to gas, like water in a kettle, it needs energy in order to happen. And they take this energy from what's called latent heat in their surroundings. Latent heat is heat energy that's all around us. We can't feel it, but it's there all the time. And they take that latent heat to power the change from liquid to gas. And as they do that, it cools the plants, but it also cools the whole environment. And that water vapor rises back up and forms clouds. When the vapor gets cold enough, it condenses into droplets again and forms a cloud. And that cloud brings the rain in a manageable cycle. And the cloud also is reflective. So it reflects some of the solar energy directly back up. So that's another way that the water cools us. And when those water vapor molecules become liquid, they release the energy they've been carrying. The latent heat gets released so it can go back into space. So the third type of pumps that plants are is their heat pumps. They're carbon pumps, they're water pumps, and their heat pumps is exactly the same process that's happening inside a fridge or an air conditioner. Going from liquid to gas, liquid to gas, liquid to gas, carrying heat, pumping it round and round, and spitting the heat out where it does no harm. Plants are the key to climate cooling. Plants and water are the key to climate cooling. And this is a whole story that's been overlooked by what they call the dominant narrative on net zero. It's not to say that net zero is wrong. It's not wrong, but it's got challenges. It's got challenges, as I said earlier. It's incredibly difficult thing to achieve, but it's not something the most ordinary communities can contribute to. You know, it's all about governments and big corporations. So we got very interested in the idea that if we worked with a project taking the emerging science and the messages that are coming from the COP meeting saying, come on, let's think more about water. And we decided to test the idea that if you work with water cycle repair, some scientists were saying that water cycle repair could be a faster, cheaper, and more inclusive way to tackle the climate crisis than net zero. And we thought, okay, let's test that idea. And we've developed a project called Collective Climate Repair, which we were lucky enough to get funded by the National Lottery Climate Action Programme in Britain. And we're working with some of the most vulnerable communities and most vulnerable people. And we're testing this principle of, do they feel more empowered? Do they find working with water something easier for them to contribute to than net zero? And that's the essence of our Collective Climate Repair project. There's different ways that water impacts the climate: by cooling, by moving energy from a dangerous place to a safe place. Those things are so integral that water has been called the global thermostat, because it's the key to how we manage cooling the planet. The problem isn't the greenhouse gases. The problem isn't carbon dioxide. The problem isn't methane or water vapor. The problem is trapped heat. And there's a group in America called the Eco Restoration Alliance, and they have said that the standard narrative of net zero jumps right over the problem of trapped heat and cooling. It focuses only on the gases and all that. But the problem, the essential problem, is cooling. And we know that the way we cool is work with plants and water. That's our project. And it's part of a growing movement around the world, all starting to recognise, and the policymakers are recognising, that water and carbon is our way out of this crazy mess that we're in. And carbon and water together has to be the way forward, and working with nature has to be the way forward. And because this conference is about diversity, I just want to add a few words about how diversity impacts on this soil, because the critical things we have to do, we have to make sure there's more plant cover. And more plant cover means lots of different things. It means more photosynthesis, it means more transpiration, more cooling. When the rain does come, even if it comes in a flood event, it's slowed down by the plant cover. The plants capture it, they act like natural sponges and natural rain chains, and they slow that water down so it doesn't all rush into the drains and it's got time to soak into the ground. Plants build soil and they put organic matter into the soil. Plants and the fungi and bacteria in the soil working together create that stable organic matter that gives the soil structure, which means that it can hold water, absorb and hold water. So all those different parts in the story, they're all taking climate action. The more research I do, the more I realise every component of the natural world is taking climate action. The more diverse that grassland is, for example, the more different plants you've got. Some of them are photosynthesizing different times of year when others are dormant. They've all got different structure, so they're catching the rain differently and they're slowing the rain differently. They're each pumping sugars into the soil at different times of year. So all the diversity plays a role. So the more diverse the plant cover is, the more effective the climate cooling is. And there are other processes at work. Even the tiniest things like mosses. Well, people think Important biodiversity is all about the rainforest. The rainforest, of course, it's absolutely central to the planet cooling. But also mosses have been found to be, per area, they capture more carbon than trees do. And mosses are natural sponges. So some research has showed that even the tiniest moss is taking climate action. Mosses and lichens are the first responders. If there is a volcano or something like that, and you're just left with deserted barren land, it's the mosses and lichens that come first and begin the process of starting to build a soil. They secrete organic acids that start to break down the rocks, and they begin the whole process of soil building, which the scientists call pedogenesis. And soil building is the essential first responder step before the other plants can move in and start to build an ecosystem. So it's not just the big trees and the rainforest, it's the mosses, it's the mix of flowers, wildflowers and grasses that make up a healthy grassland. And it's even things like snails. Because one of the other most important climate cooling process that goes on in the world is not biological, it's mineral. It's a thing called carbonation. Carbonation is where carbon dioxide combines with a mineral like calcium and forms something like calcium carbonate or calcium bicarbonate, chalks and limestones. If you talk to a geologist about carbon capture, they're not worried about plants. They know that rocks do the heavy lifting. Rocks do more carbon capture than plants do, mostly through that calcium carbonation, calcium carbonates. Plankton in the ocean with little shells, they do that in gigatons every year, and it's those plankton shells that form the massive chalk deposits that are like the cliffs of Dover. All that chalk and limestone comes from a climate cooling process that the tiny plankton do. But even in your garden, a snail is using exactly that same process of carbonation to make its shell. So in your garden, the mosses and the snails are taking climate actions, and the wildflowers are taking climate action. And they're using exactly the same processes of climate cooling that make the rainforests so important and make the oceans so important. Exactly the same process happening in everybody's garden, everybody's patch. And we wanted to take that story out and tell people, look, you're part of the same systems and part of the same cycles that's happening globally and been happening globally for millions of years. And it's these systems that keep the whole planet cool and keep the planet safe. If everything from rainforests to local trees, shrubs and mosses and the snails in your garden is taking climate action, those things are empowered, and you can be too by working with nature. That's collective climate repair.